All right. Hello, everybody. Welcome to your first video lesson in Unit 2. Like we talked about in class today, this unit's going to go a little differently. You're going to be, for homework, watching some short videos that will either introduce or teach you new topics. And then in class, we're going to be doing a lot of neat group work, partner work, and just a lot of practice of the topics in class. So I think you guys are really going to enjoy it. So when you're watching these videos, you want to make sure you're taking notes on everything. I'm only including the necessary information. So your homework grade is going to come from Jonathan's favorite classroom assistant, Ari, is going to come around and check in to make sure that you have all the notes and examples. And if you do, then you'll begin the full score. So again, your homework is taking notes on these videos, doing the problems, asking them, and then we'll check those in when we get back to class. First lesson this unit is going to be 211, the basic moves for solving equations. Okay, well, if we're going to talk about linear equations, we should know what they are. Linear equation, as you can see, and yes, you should be writing this down. Feel free to pause the video at any time if you need a little bit more time to write. But linear equation is an equation in which the variable terms are raised to the first power. And that being our key word here. So let's take a look at a couple linear equations. So the equation 2x plus 7 equals 10 is a linear equation. Even though we don't see the x being raised to the first power, it's understood that if you have a variable without an exponent, that variable is being raised to the first. Okay, the type of linear equation that we're going to graph later on this year would be y equals 2x minus 4. Okay, even though we have two different variables, they're both still being raised to the first, so they're both linear equations. Okay, now this last one here isn't a linear equation, and I want you to know this. Why? Don't roll your eyes at me. Think about why it's not. The reason why is because this variable, the x squared, isn't being raised to the first, it's being raised to the second. Doesn't matter that this x is being raised to the first. If you have one that's being raised to a bigger power, automatically makes it not a linear equation. Okay, so that last type we're going to learn to solve later on this year in second semester. But what we're going to focus on in this lesson is solving linear equations like the first one. Okay, so we've already talked about some ways to solve some linear equations. One method that we've used is backtracking. I know you all enjoyed it so much. You know, backtracking has a lot of value. Again, the reason why we took the time to do it is because it gets you thinking about mathematically how those equations were created. And why that's important is it helps explain why we undo the steps the way we do, right? We're slowly unraveling the ending of the equation, right? Doing the steps in reverse order, doing opposite operations to get back to what we started with. And that's really the value behind backtracking. But now that you guys have mastered that, we don't necessarily need to write out the steps every time. We can kind of just get right into the math of it. Okay, I might talk about some things with backtracking, but we're just going to jump right in. So the method we're going to use starting today is called the algebraic method. So the algebraic method, also known as the basic moves method, involves us solving equations by focusing on keeping the equation balanced. Okay, you're going to do the same basic moves to each side of the equation. And since you're doing to each side of the equation, you'll stay balanced and they'll be legal and we'll get the answer that we need. So let's go ahead and jump right on in. Okay, an example of the algebraic method. Here we go. The equation we're going to work with first is 3x minus 5 equals x plus 7. Okay, step one, solve for x. What's it mean to solve? Well, we said before that the solution is the value that makes of the variable that makes the equation true. Right. Okay, good. So since we want to look for the value that makes of the variable that makes the equation true, we need to get the variable alone. We need to isolate the variable. So anytime you see this idea that we have to solve, you want to think, I need to isolate the variable. because solving is trying to find out what value of that variable will make the equation true. Okay, so to isolate the variable here, number one, you first need to put the variables on one side. Now, I like to keep my variables positive, so I always try to keep my bigger amount. I'll leave that one alone, and I'll move the variable that has the smaller amount. So in this case, I'm going to move my x. I want to take it off the right side, move it to the left. Well, how do you take something off? You subtract it. So we're going to subtract x from the right side, equal sign. Whatever you do one side, you have to do the other. So we subtract x from the left side. Okay, that's going to give us 3x minus x is 2x minus 5 equals 7. Okay, now again, we're trying to get to just x. Okay, so next step, let's move that 5. So let's get the variables on one side, the numbers on the other. Okay, well, this is a negative 5. So how do you undo a negative 5? You add 5. So we're going to add 5 to each side, and then we're left with 2x. Negative 5 plus 5 is 0. That goes away. 7 plus 5 is 12. Well, now we know 2x equals 12, but we want to know what 1x equals. So right now, what operations are connecting the 2 and the x? Multiplication. How do you undo multiplication? You divide. So when we divide each side by 2, we have 2 divided by 2, which we all know is 1. Okay, so we get x equals 12 divided by 2 is 6. So right now, we think our solution is, hey, x equals 6. Okay, well, now we want to check our solution. What did we just say? The solution is the value of the variable that makes the equation true. Okay, the way we're going to check is we're going to substitute in the solution, abbreviate SOLN, and see if it makes the equation, abbreviate that EQN, true. Okay, make sure you're getting all these notes down. I know realistically you might not always have time to check every single problem, but when you can, that's worth it. You want to know that you're accurate. You want to make sure that you're doing things right. Okay, so we're just going to take the steps we just said. So I'm going to just go ahead and plug in my variable. So 3 times 6 minus 5 equals 6 plus 7. We know the multiply, so then we have 18 minus 5 equals 6 plus 7. 18 minus 5 we know is 13. 6 plus 7 is 13. Hey, it made our equation true. X equals 6 is the solution. Okay, nice work, guys. All right, so what I want you to do now is go ahead and pause the video, and I'd like you to try these two examples right here on your own, and then check your solution too. I do want you to actually practice that skill right now. And then when you're done, you can play the video again, and I'm going to walk through the steps so that you can check your work. Okay, have fun. All right, so just like we talked about in the previous example, I'm going to leave my bigger amount of the x alone, and I'm going to move my smaller. So I'm going to take my 4x off my left side, which means I take it off my right, and then I have 3 equals 3x plus 15. Okay, remember, variables on one side, numbers on the other, so I got to move my 15. I'm adding it, so I subtract it to move it. I subtract 15 from each side. Notice I keep saying each side of the equation. What I'm talking about is each side of the equal sign. Some students find that helpful to draw that right on in. Okay, 3 minus 15 is negative 12. On this side, we just have 3x because 15 minus 15 is 0. We want to find out what just one x is equal to, so we have to get rid of that 3. How do we undo multiplying by 3? We divide by 3. So we end up with the solution of negative 4 equals x. We're going to check our work. That's important. So we're going to do real quick here on the side. 4 times negative 4 plus 3 equals 7 times negative 4 plus 15. And I know you've all done this on your papers. It's totally worth your while. Okay, so then we end up getting negative 13 equals negative 13. Hey, it's a true equation. We got the right answer. Okay, now in 2, what was different here, hopefully you know this, was that this was a negative 2x. So before I was always subtracting that amount. When it was positive, I want to get rid of it. Well, if I want to get rid of negative 2x, I have to add 2x. Remember, those are additive inverses. They're going to add to 0. So I'm going to add 2x to each side. So we now have 8 equals 9x minus 15. Get the numbers on one side. So I add 15 on the right, which means I add 15 on the left. So we now have 23 equals 9x. I want to find out what this 1x is. I'm multiplying by 9, so I undo it by dividing each side by 9. And we get 23 over 9 equals x. Now, I think a lot of times students see fractions and they think, oh my gosh, I made a mistake. Just like when we kind of were going over the homework today. But remember, you can get fractions, and you're going to see fractions more and more now in kind of these upper levels of math. So we're going to go ahead and plug this in. Next class, I'm going to show you guys how you can check on your calculator, which is really helpful for these ones with fractions, because I think even though I'm saying we can get fractions, we all get a little nervous that we get fractions. So this will be a way for you to just be able to check really quick, hey, it's okay for me to get a fraction, this is right, and be a little bit more efficient in your time. So remind me to do that next time. Okay, we know we need common denominator, so really quick, 8 over 1, I'm going to do times 9, that's 72 over 9. Negative 46 over 9 plus 72 over 9 equals 161 over 9 minus 15 over 1 times 9 times 9 is 135 over 9. So we're subtracting 135 over 9. Negative 46 plus 72 is 26 over 9. 161 minus 135 is 26 over 9. That is true. Nice work, my friends. Okay, last thing we're going to do then. I want to talk about solving equations efficiently. So many of us have kind of gotten used to always just distributing. And to distribute the 4 here would mathematically not be wrong. You can totally do it. My concern is that I see, we all make those easy, careless mistakes. And when you distribute the 4, you're actually making an extra step for yourself in the problem, which leads to 1, more work for you, and 2, more opportunities to make mistakes. So I like to try to minimize those opportunities. I like to minimize my work. So I'm going to kind of think about this through the backtracking we talked about, which will help it be a little bit more efficient. So in backtracking, we listed out the steps that created this, and then we undid each step. Well, if I were to make that list that created this equation, the last step would have been adding 13. So that's going to be the first thing I undo. I undo adding 13. I subtract it. So I'm going to subtract 13 from each side. Okay, so now I have 4 times the quantity of x minus 7. The 13s are gone. 27 minus 13. Let's make this, I meant to make this a 37. Sorry, guys. Okay, so we're going to say equals 24. All right, so now, if I had the steps that created this equation, I would have had choose a number, subtract 7, multiply by 4. So now the multiplying by 4 is the next thing I undo. You undo multiplying by 4, we divide. Now we have x minus 7 equals 6. We add the 7 to each side, and we get x equals 13. Again, could you have gotten the answer using distributive property? Totally. Am I fine with you if you do that? Absolutely. I just think that if I can find ways to minimize my work and to avoid opportunities for mistakes, I like to do that. Okay, I'm just going to go ahead and show real quick that checking. So we have 14, 4 times 13 minus 7 plus 13 equals 37. So that would be 4 times 6 plus 13 equals 37. Lo and behold, there we go. 24 plus 13 does equal 37. Nice, people. Okay, go ahead, pause the video, and solve this next equation. Again, you can do it a couple of different ways. I'd recommend trying my approach, at least see how you feel about it. And then when you come back, we'll check it. Okay, so my approach, I'm going to slowly unravel everything outside. So I'm first going to get rid of my negative 11 by adding 11 on the left, which means I add 11 on the right. Then I'm going to have negative 2 times the quantity of 4x plus 5 equals 6. Still unraveling what's outside my grouping symbols because we know those would come first when we make the equation. This would be multiplying by negative 2, so I'm going to divide each side by negative 2. So I get 4x plus 5 equals negative 3. I'm going to undo that adding 5 by subtracting 5 from each side and get 4x equals negative 8. And then my last step, I want just the x, so I divide each side by 4 and we get x equals negative 2. Check my answer real quick here. And we have negative 2 times the quantity of 4 times negative 2 plus 5 minus 11 equals negative 5. Order of operations tells me to multiply in here first. Then we do negative 5 plus 8 is negative 3. So then we have 6 minus 11 equals negative 5. Yeah, buddy. Nice work, you guys. You survived my first video lesson. All right. I hope you guys enjoyed this. Like I said, you should have taken all notes on everything, all the notes that were on here. There was nothing on here that was kind of unnecessary. It was all important information. You're going to take the notes. Hopefully you try the problems and pause the video. And then when we see you on Tuesday, we'll check this in. And like I said, we're going to do some really kind of neat, fun things to be doing some practice and really mastering these skills. So I hope you guys all have a great weekend, and I will see you on Tuesday.